hash, and it will give you the logs for that container. Or you could be like, yeah, I want to grab the name instead. So the name is here. And it's all very nice and hacky in the sense that you can just take a lot of similarly duplicated identification mechanisms and just say, I want that by its container ID, or I want that by its container name, or I want that by some other thing that I haven't even thought of, but undoubtedly there'll be many ways of getting the same output. So I am running Mosquito on my container, on my laptop, and any device on this network, if it wants to, can grab my IP, submit MQTT messages to it, and forward them all over the place. You see, it's quite messy. It creates a bunch of, it creates a lot of network devices in order to get its job done. And this is simply because I haven't removed all of these networks. So I'm going to do that now by using a command that I made called docker nuke, which will get rid of every container that I have on my system, which is a developer's worst nightmare. And then at the end of it, it will print a nice nuclear weapon. So now that we've done that on my laptop, we should probably end up doing that on a brand new Raspberry Pi. So let's do it. Has anyone got a spare Pi? No one's got a spare Pi? Well, actually, this is probably beneficial. So, oh no, not anymore. It's not. It's going to take too long. So actually, I'll demonstrate a nice feature of Balena, which is the fact that when you use Balena, every device becomes a big grey box that you can do that on magically with a file from, say, your laptop in the world, anywhere in the world. You can say, I want that Pi to become something else. And that also means that you don't have to flash any SD cards anymore. Isn't that great? So I don't have to plug this SD card into my laptop anymore and flash Raspbian or flash Fedora or flash Arch or flash anything to it. I can simply make it become anything I want it to become magically. So this 3D printer right now, for example, I'm going to turn that printer into a MQTT broker. Don't believe me? Okay. Let's go to the Balena dashboard. So this is what my setup looks like. I've got Ming-home at home. And it is doing all sorts of things. It's doing temperature via this sensor that Julian gave me, if you want to zoom in on that hacky mess. Looks like a bomb. Yeah. It's got an infrared sensor on it, and if I put my hand in front of it, it will get really hot because it's only infrared. So I'll give a demonstration of that soon. And all that's doing is outputting MQTT messages on the Mosquito broker that's running on Ming on the Pi that I've set up with Balena. So let's turn this printer, this otherwise functioning poor printer, which is available at 10.0 or 5.0.2, yeah, and is existing in the free-octopi application, which houses all of the printers at does. And we can say, OK, I want to take this Pi, which is Matt's Ender 3, which I've named. And we're going to move that to, let's say, LUG for now, since I made that in advance. So that is no longer a 3D printer. And I don't have to flash an SD card to make that happen. It now exists on its own little application, as it's called. And an application is just a Docker file and a Docker Compose file. The dashboard turns that into a quote-unquote application, which you can then push to and do all sorts of nice things with the Balena command line with. Well, I'll skip that demo for now. Let's deploy Ming to the printer instead. which is Mosquito, InfluxDB, Node-RED, and Grafana. So in here we've got Ming, the latest Ming from the Ming GitHub, github.com/dynamicdevices/Ming. And then we can simply say Balena push to LivLug. And we should hope that Alex didn't screw up the master. Right, so we did screw up the master. That's okay, though. That's okay. Yeah, I can. I'm going to do that now. So there it is. There's the blames. Yeah. They're all from you. So, yeah. Is it just that one, Alex, you think? WebSocket, yeah, it is. So push that to LivLug, and now it should work. You have to do hard. You have to do git reset hard to make that happen. Yeah. What this is a little bit of a bug in Balena, so we'll just gloss over that for now. So it's going to now take all of the files in my current directory, which includes the Docker Compose files and the Docker files, which contain instructions of how to build systems, and it's going to push it to LivLug. Hopefully, Balena have not changed things since I last used it. Everything always works the first time. That'll be it, won't it? Yeah. If anyone has any questions, by the way, feel free to just completely interject and interrupt me, because it'll make things a little bit more lively. Because, oh damn. Potentially.
I've done nothing, so I haven't contributed anything or broken anything to the solution, so that we can contribute stuff as well.
There we go. So going back to commit on the head at the moment, to before Alex submitted this pull request. Oh, it is. So it's going through, and it's taking, say, 4 things that I want. I want InfluxDB, Node-RED, Grafana, and Mosquito. And it's going to go through all of those different Docker files that I've made to make that happen. And it's going to commit to all of the steps. I've even got JupyterLab in there. And it's running through all that in a virtual machine in the cloud on the Balena Cloud Builder. And it will take that. And once it's done with it, as long as there's no errors, no exit codes above 0, then it will deploy it to the Pi over the air. And that is scalable from this Pi to a cluster of Pis over there in the corner that is running 3D printing software. This might take a bit just because of JupyterLab, because it's quite a behemoth.
Are they already the same in the version?
Yeah, so that's another thing, is that you could have a bunch of devices on the Balena Cloud that have different tags. So it's like I want my version to be called 0.1, and I want this printer to be on version 0.1, and then selectively say I want Alex's CR10S to be on 0.2 instead. And you can do all of that in the Balena Cloud.
While this is building, you're mentioning about systems. Can you talk a little bit about how you can manage persistence of the containers?
Yeah, so I'll do that by demonstrating with the Ming stack as well. So let's take a look at how the Ming stack is actually built. So what container are people most interested in finding out how it's made? So we've got InfluxDB, Node-RED, Grafana, and Mosquito. Node-RED, yeah? Because that's usually a bit of a mess to install because you've got no package manager going on and everything, right? No, I mean, that's a good example because that's a messy one. That's how it's built. I let someone else do it for me. So I simply say, I want from the official Node-RED image that they've made to work on any machine in the world. I don't want to reinvent the wheel, and I don't want to duplicate work. So I'm just going to pull from them. So let's go on the web, and let's find out how they've done it. So they should have the source somewhere. Been here before. This is not that exact Docker file, but the source can actually be sometimes hard to find because people don't necessarily always put it on hub.docker.com. But let's just assume, for example, that it was this. All it would be doing was saying, OK, I'm going to pull from someone else's work, which is a running theme. And that looks like a version of Alpine Linux. And he does that because presumably he wants the file size to be lower because Alpine Linux. I don't actually know all of the reasons why it's like that, but Alpine Linux tends to be smaller. So then it will run make directory, and it will make a directory that it presumably wants to use later. It will make -data, which is presumably, and this is often a convention, which is where all of the persistent data that you don't want to go missing the next time you build the device is going to go. But everything that's /data is safe, let's say. And it's going to set the current directory, which is the work directive. So we are now in user source Node-RED. Then it's going to run add user. It's going to set the ownership of /data to the Node-RED user, as well as the user /src. Then it's going to it's going to set itself to be the user. So in this container, we are now running as the user node-red. Then it's going to copy package.json from the Git directory that we just pushed everything from into the container, so we can control all of our source files, like all of our configuration files, and then make changes to them, and everyone can see what we've done to them. Then it's going to run npm install, and it's going to make a volume, which is just, imagine it like a virtual disk, which is going to store all of our persistent data. It's saying everything in data is persistent. And then it's going to allow network traffic on the machine to go through to port 1880. And it's going to do a bunch of other semantic things, like that is an environment variable. It's simply saying that in the container, at runtime, flows is equal to flows.json. And then it runs npm start in the current directory that it's in, which is user src node-red. Yeah. And it's done. Nope, that's fine. So it's not using the screen, it's not pushing to the screen, but believe it or not, that Pi is now running all of those applications, or at least it should be in some capacity. So we can check on the progress of that on the Balena dashboard. So in the LIVLUG application, you can see it's set to updating. Keep in mind, this can be used for any number of devices. You could have 10 Pis here, and they'd all be updating right now. So you can see, it's only downloaded what it needs to, and then ran it. So for example, no. I was assuming that we were running Mosquito for some reason on the machine in the first place. But if we were running Mosquito on the printer previously, when we sent that, it wouldn't have to update that container. That container wouldn't stop, and it would continue running as normal, and nothing would be interrupted. So in the meantime, whilst that's updating, I'll get on with the presentation. After this, I suppose I'll show you graphing a temperature sensor with all of the stuff that I've just pushed to this. So we're going to graph a temperature sensor like this one with that Pi that is supposed to be a 3D printer. and then we're going to change it back from a 3D print, from a temperature sensor monitory thingy into a 3D printer again. Suppose, any questions? Yeah, so I think you can use it for pretty much anything you can build it for. I mean, you might want to actually get into that if you want to build it for, like, by default, they offer you a lot of things. So you look at all these boards. These are all single board computers that you can do this on. And they're adding more every single day. And it's all, again, open source. And you can add to that or do it yourself, like I said, with Open Balena. Yeah, like the upboard. Raspberry Pi 1, the original Pi. Yeah, so you can run this in a virtual machine. I've thought that this might be a good idea. For example, if you're running something like Proxmox, or you just had a virtual machine on your computer, you can just run that in a virtual machine because you feel more comfortable there. And then your virtual machine becomes this theoretical system that's just like a Raspberry Pi. It's probably quite a nice way of doing things in and of itself, quite a secure way of doing things as well. Since it doesn't even have the SSH port open by default. You can't SSH into these devices. You can only get in there through the Balena CLI, which is a new way of doing things. It's a new agent, so to speak. But yeah, it's just a nice way of doing things.
So you've got community ones there as well, like Orange Pi.
Yeah, these community builds are supplied by the community. They may not keep them up to date, which means that you're probably better off in that circumstance running Open Balena on your own server. Right. Has anyone got any ideas that they want to do for this sort of thing? So, because I could probably make a system, a theoretical system. I know Seb's got like an irrigation system.
Oh, you want to make an irrigation system? Well, you've got a teapot there, so you've already made some tea. So we could irrigate the onions.
Hmm.
Yeah, that's true. What about one of the camera type things that we've got?
Oh God, that'd be a bit of a mess. I mean, the Octoprint. Sometimes these things take a lot of time, yeah. So, but the Octoprint container does actually make use of the camera, for example. Yeah, we'll do that in a moment. Once we've graphed out, so that's all working right now. So we'll see that Mat Ender 3 is now not a printer at all. Here's the logs for the device, which again are stored in RAM, and actually that's quite beneficial because say the device goes down and you've got no way of accessing the device. All the logs have then been outputted to the Balena cloud, or in the case of Open Balena, to your server that's running somewhere in the world. So the logs are never necessarily stored on the device because that would kill the SD card over time. And instead, they're piped out to a remote server, and you know what happened to it when it died, at the very least, which is quite good. It's quite a good way of doing things. And it's going to come in really handy if we deploy this buoy in Hull, and it's not very buoyant and it crashes, and we don't know about it. We'll know probably quicker than anyone in the area because we'll know that the Pi went offline, for example. Could have went offline for many reasons. But let's say we had like a humidity sensor. We'd know pretty quickly. And yeah, I've got nothing to say other than it beats manually doing this on a server with systemd and having to manually specify a lot of things.
What's the limit there? Is it 10 devices per
10 applications. So actually, you can have as many. You could have 100 devices on this if you want.
But presumably, I mean, they want you to pay at some point, don't they, for the Balena cloud?
They do, yeah. And
There's a tiered system.
it's quite pricey actually, but I don't really think they intend for many people to pay for it, except for like organizations and big people. And again, you can set it all up yourself with Open Balena.
Yeah.
Which right now it's not running on port 80, but I will demonstrate in a moment how you can get things to run on port 80 and then access it from here. I'll demonstrate some of the tunneling functionality, but it gives you the IP address it thinks that it is on the local network that it's on. So we can connect to that, and let's say we want to access Grafana, we can do that on port 3000. And that's running on this Raspberry Pi right now in front of me. And of course, Node-RED is also there on 1880. and it's also running InfluxDB and Mosquito. So let's get this temperature sensor on the network and start piping it out to Grafana. I may not be able to do that. If this cable is not a data cable that I can use on my system, then I don't think I'll be able to do that. Let's find out. Yep, out of luck. Guess we won't be doing that then. Data cable, cable that outputs data rather than just power. USB, regular USB. Yeah. Just a regular USB. This one is this one's power only, so it doesn't output data. So I can't do anything with the device. Yeah. Micro USB. Yeah. What's that? No, it's just some some cables only come with power pins. That's right. Yeah, so that's what I've ended up with. Thank you very much. Hey, there we go. So the device shows up. So let's program it. Using Jupyter Lab, another one of Julian's favorite tools. It's going to open up in Firefox. 7. Yeah, that's all of Julian's incredible code. Right. So this little device here is something that Julian programmed, and it is running MicroPython and a big script that he's written to output values from the temperature sensor over MQTT. The only problem is it's not connected to the Wi-Fi, so let's do that. So we're going to use the Jupyter MicroPython kernel to do that. It's got a bit of a dodgy cable on it though. So first things first, we need to get into the device to actually see what the configuration file format looks like. So I'm going to do that using MPFS shell. Oh, just add that back in. It's on USB 0. Couldn't exec command. Not had that before. Everything always works first time. It is, yeah. Open TTY. Oh, maybe it's /dev. It's probably 1 now, isn't it? Open TTY USB 0. Okay, maybe I've just got to catch it as it runs the code. That'll probably, yeah, that's it. So what I have to do is I have to catch it before it starts running its main.py file. TTY USB 0. Right, so now I'm connected to it. I can ls, and here's all the files that are on that device. In I'm not quite sure how it implements the file system, but it's quite nice. And we can cat the configuration file to see what format it's in. No one, Julian, it'll be quite simple. So now you've got my Wi-Fi passwords, so that's good. Yeah. Yeah. Next, you'll see my credit card information, which is also stored in the I store all of my personal information on ESPs. That's what I do. Yeah. Right, so we're going to overwrite that file using Jupyter, just because it happens to be quite a lot simpler to send files to the device when you do that. So you know what well, they're also going to know the Wi-Fi username and password of does now as well, which is quite, damn it, yeah.
So just obscure like a shot of the wall for a bit.
It's very secret, this.
I'm switching it to camera.
And if we wanted, we could use the, and I think we are going to use it, we're going to use mqtt.local, which is the resident MQTT broker that we've got running here. It does, instead of the one that's on the Pi, just to make things a little bit simpler to understand and explain. The MQTT broker is going to be 10, do you know what the IP is, Alex? 10. Let's just use itself. We'll scrap that idea. 10.0.50.2, which is the IP address of this Pi, which can be set in a number of ways. But right now it is static according to the network configuration. And we're just going to send that to a file called config.txt. Using handy dandy MicroPython kernel by Julian Tards, resident of the makerspace. Config.txt. That sent that and overwrote the existing config file. So the next time I power this device up, it's going to connect to the local Wi-Fi hotspot here. Then it's going to connect to the MQTT broker at 10.0.50.2, which happens to be that Pi. And we'll be able to monitor those messages. So I'll do that after I correct the capitalization of the Wi-Fi network, just in case it doesn't work. Right. So to monitor the network, we're going to be, to monitor the MQTT broker that's now running on there, we're going to do mosquito subscribe to a host of 10.0.50.2, which is this Pi, and the topic is going to be everything. In quotes. So nothing's happening right now, but when I unplug this and plug it back in, it should start outputting messages on the Wi-Fi in around 10 seconds or so. There we go. So it's broadcast its IP address, its MAC address, and now it's outputting temperature values, 2 values. Now if we specify V, I think it gives you the verbose output. Yeah, so that's the topic that it's on. Hello there, you've done the same thing that I did to Julian. Yeah. Wonder who did that. So now my security is being ruined. Alex can fake readings, and he can make me think that my house is on fire when it's not. Thank you for that. So now we can graph that, and we can put that into Grafana. So let's do that. So in Node-RED, we're going to say we've got MQTT in, listening on, the local broker, which is called Mosquito, which is the host name that we set in the Docker Compose file. We said we're going to make a service called Mosquito, which means it's going to be pingable at mosquito.local, or just Mosquito on its own. And that's all we have to do for the configuration there. And we want the topic, want that topic, IR for infrared. And whatever value comes out of that is now going to be visible. So you see, now the string is in the message payload. The payload of this, the output of this, is a simple string called, well, there it is. And now all we have to do to get that into Grafana and visualize it is to simply put that into a database, which is also very simple and requires no code whatsoever, except for the code that's being written by giants. And to do that, I'm actually going to copy, because I've forgotten how you do this. And in order to do that, I'm going to demonstrate the tunneling functionality, and I'm going to tunnel into the Pi that is running for that project that I was talking about in Hull with the buoy. So to do that, I'm going to run Balena tunnel into win-pi, which is the name of the application that contains the Raspberry Pi that I'm talking about. And I want port 1880 on my machine to become port 1880 on that machine. And now, if I go to 127.0.0.1 or localhost 1880, I will be in the wind factory, which is a few miles away. And there you go. There's all that project work. So that's Pi somewhere else in the world, tunnel to via the Balena CLI in such a simple manner. Also logs the packets that go in and out on the remote ports and all that, which is quite nice. So it's this convert to float that I always get wrong. It's like a JSON expression which I've never heard of before. Yeah. So all I have to do is get a change node, which means change whatever this is, the payload of this, the output of this, which is a string, into a number, because we can't put strings into a database and do anything with it. So let's take the output of that and copy from here. So yeah, all I did was say that the payload is equal to a number. And that's it. So now, instead of being in quotes when it comes out of the debug, it should be a regular number. So you see now it's a number, and it knows it's a number. So now, we should go here, manage the palette, and we're going to download the InfluxDB node contrib, which is just a node that someone's made to make it easy for us to publish stuff to InfluxDB. Read the log of that. So that's all running in the container right now. And I'm pretty sure we'll be able to see the logs of that if we went to the Balena cloud and then filtered by node red. So the service is node red. So you see, here's all the regular logs, and it says there that it's getting node red. Wrong one. Right, it's done. So now we can output that, instead of into a debug, into the database. Influx out. Where are we going to put that? You guessed it, into a database that is documented called Ming_default, which is the default name for the database that is created and instantiated when you build the container in Ming. And there's no need for a username or password by default. And container's host name is InfluxDB. So we deploy that. And now, because I cannot be bothered, we're going to Balena SSH into that container, the InfluxDB container, to see if that worked, to see if it's actually outputting values into the database. So Balena SSH into LIVLUG. And then the container name that we want on the device could be Croughan, it could be InfluxDB. In this case, it's going to be InfluxDB. Your SSH keys are taken from GitHub or other sources when you sign up to Balena. If this was your own personal open Balena that you set up on your own server, you'd have the option of telling it what keys to use and stuff. So now we're in the influx container, and we can see, well, we don't even have top. Is this Alpine? We won't bother. PS orgs? Don't even have PS. Got nothing. Very much so. So we're just going to run the influx command line and see if what we just did is going into the database. And I know it won't already because we never made up a name for the measurement. In InfluxDB, you make a measurement and then that instantiates the field. Oh, the field. Measurements, yeah, say we've got a number coming in and we want to call that number something. We're going to call it wherever we want, and that's going to become a measurement. Yeah. Yeah, but it's not like a traditional database. It's not. I'll be honest with you, I'm not actually sure what the difference is. I just like the way that you just call it something, so we could call that temperature. No. Nice. And if we go over here, what workspace did I put that on? There we are. So now we can show databases. We've got Ming underscore default, we're going to use it. And now we want to show the measurements. Did we actually output? Yeah, we did deploy that. And we got temperature, so there it is. So now it's outputting values to the temperature measurement in the database. And then I think we can select all from temperature. Is that going to work? Yeah. So, yeah, I think that's nanoseconds epoch time. Yeah. Nanoseconds since 1980. 1970. I've got that wrong already. Yeah. I'm not old enough. Yeah. Right. So now we can go into Grafana instead of this, and we should be able to just simply observe that with absolutely no code written whatsoever. We make a new. God. Anyone see the new dashboard button? Oh, I've got to log in, right? Admin, of course. Lord knows Alex is probably in there already trying to troll me. Right. So we want to take it from the already made for us, automated InfluxDB, which we would have otherwise have to set up in some setting menu somewhere, which is done by the Docker Compose file and the Docker file that I've written. I've simply done the steps that ensure that the InfluxDB container is there by default and already connected. We select the measurement called temperature, and it's already starting to plot it. So there it is. That is the value of that temperature sensor on a graph with absolutely no code written, using Balena to put something onto a Pi, which, by the way, for you as an end user, would look like you flashing an SD card and putting it in, and you would get all of that. Yeah, and in fact, I'll prove that in just a moment. So let's say I've got a Pi here. Raspberry Pi, it's got nothing on it, doesn't even have an SD card in it. And I want that to do the same thing that that's doing right now. So what I'm going to do is, I'm going to flash the Balena image from the Balena dashboard that has been made. Like I said, my own personal distribution of Linux, essentially. I'm going to make a new device. And it's going to be connected to the Wi-Fi, which everyone knows. And that's it. For Raspberry Pi 3. There is a command in Balena to do this, and I'm not sure why it's more efficient than DD, but it makes more sense to use it than DD. Because for some reason it executes faster, and I think it has more of an understanding of what goes on with SD cards and wear leveling and things. I've got no explanation for it, but it often flashes in like 2 or 3 minutes, whereas DD usually takes upwards of like 6 or 7 for some reason. Probably something to do with the block size and optimizing it for SD cards. So sudo balena local, so it's a local command that's running on this system, flash. So there's the image to the drive /dev/mmcblk0, which is right here, which we see having been inserted there. And presuming we've got gigabit, I won't have to check the download to see that it's done. It's now flashing that to that SD card, and once that SD card is flashed, I'll simply plug into the Pi, power the Pi, and it's going to then download the whole, well, I'm still going to call it a distribution of the Balena cloud, which again could be your open Balena that you've set up on your own server somewhere to do all of this orchestration and automation of that Pi. So, whilst that's cooking, what else have we got? Right. Well, showing you that. We'll do the vinyl cutter soon. Tunnels. So I showed you that we could tunnel into the buoy pie or the wind pie to get access to node red somewhere else in the world on a pie randomly. That's because Balena sets up a VPN by default, which all your devices are connected to, and you can selectively tunnel into those devices by name. So in the same way that if anyone is familiar with Docker here and has used Docker extensively, then you'll know that you can just do like Docker logs or Docker compose logs or Docker run, and then you have to specify key identities for like the container. And this makes pies into devices that you can do that with anywhere in the world. So for example, let's say I wanted to see the logs on the device somewhere else in the world called WinPy. So I would just do Balena-CLI, oh no, it's just Balena, logs of win-pi. Device not found, WinPy. What's an A, maybe? Application name, win-pi. Missing UEUID or device, win-pi. Well, let's just list all the devices first. This is the real power. You know, this is probably the command that I should have started with. Is that is every device that I have running in the world somewhere, and I can magically go into those things based on their hashes, just like I can with the Docker CLI. Except this is no longer running on my local machine. This is just like, these are the pies in the real world, and I can interact with them. So let's. A shorter terminal. Yeah, I just needed, I couldn't see it because it was too big. Yeah, so that is the container unique identity. So I think I could just do Balena SSH into that. And it'll give me probably access to its host system, which is all read-only. And then in that host system, I can run Balena PS and see all the containers that are running. Right, so I suppose it's a bit like Kubernetes in the sense that you can go and see all of your pods in Kubernetes. They call them pods, and pods are devices that run in the world, much similar to these pies as just nodes in a network. And then you can see all of those nodes and interact with those nodes, so it's very similar to that in a way. They've all got names, and you can use the name instead of the container ID hash value. Yeah, but I think it's self-explanatory. I don't know if I can really demonstrate any more than this. Everything you can do in the dashboard, you can do in the command line from anywhere in the world. So that includes tunneling to them in various different ways. Yeah, so like I said, no more reflashing SD cards. My 3D printer can be Ming if it wants to. And if you don't want to be a part of the botnet, then of course you can set up Open Balena on your own server and handle everything. I think I've repeated myself enough on that point. I'm just trying to stress. What's that? Sorry.
You know anyone who's doing that? I don't know.
Alex is running Open Balena, and I'm running Open Balena.
Who are you? When did you get it? Oh, okay, cool.
I didn't quite get around to setting it up. I did set it up, but I didn't get into the documentation enough to be able to demonstrate something.
I'll have to play around. I'm just curious how easy it is to run host.
It's actually really easy. Yeah.
Docker on top of Docker on top of Docker.
Yeah. So I set that up last night in like 5 minutes. The most annoying part was actually setting up my domain, not the actual software setup, because you have to set a bunch of CNAMEs for like APIs and yeah. So I can show that off at some point once I get that done at a future LUG. Yeah, so I suppose I can show you how I would, for example, add an existing container onto a project. So let's say I want to add a new application called capacitor or chronograph, which is like a nice little graphing tool as well, just like Grafana, onto an existing project. I'm going to show you how you do that. So let's cd into my presentations directory. So, cd into Ming. And let's say I want to add a brand new application. I will make a directory, and I will call it capacitor, because that's the application that I'm getting. I'll cd into the capacitor, and I will nano a new Docker file, template, not Vim, because I'm a noob. And now we're going to start making the machine. In my circumstance, because I'm lazy, I'm just going to go on the Docker Hub, and I'm going to look for capacitor. Yep, looks good. It's got documentation of its own. It says that the persistent directory is /var/lib/capacitor, and that I should make a volume for that. So I'm simply going to say, OK then. Let's build our container from capacitor. Actually, that will work because it's an official Docker image. You can say what version you want. So most Docker containers have tags, and you can say what architecture you want it to be. You can say what version you want it to be. So for example, let's say you chose latest, and then you did a big update on your system, and everything broke. Write this up. Speaking of everything breaking, yeah. So let's say everything breaks because you use the latest version or something. You can roll back that whole container back to a previous version. Now imagine trying to do that on, like, say, CentOS or something, or Raspberry, and it's like, oh no, I updated my entire system, and now Grafana is a new version, and I can't roll that back very easily. Containers change that fundamentally about the way that you operate and use your systems, because you will never really need to worry about the semantics of a package manager ever again, because once it's all done in a Docker file, you never have to worry about the host system so much, unless there are missing kernel modules or something like that. So let's implement this in the setup. Due to a bug with Balena, there is a requirement to specify which architecture we want to build for, which Alec recently sorted out, but means that we can't use the cloud builder because of another bug. But providing we are strict with the way we do things and don't expect everything to be automated, then we can just say platform equals Linux, not Cubics. Platform is Linux/ARM/v7. And that's it. I mean, maybe we want the latest. 1.5.3 happens to be the latest. We could choose latest if we wanted to be, but I'm going to just keep it at 1.5.3 for now, just to prove that it can be flexibly managed. Then we say in the Docker compose file, which tells the whole system how to run all of these different containers simultaneously, we want to add a new volume to say what we want to not go missing the next time we run or build the container. So we're going to say, OK, we want capacitor dash data. We're going to make a new service called capacitor, which means its host name is literally going to be capacitor. We're going to restart it always so that if it crashes, then it restarts. We're going to build from /capacitor, because that's where the Docker file is. We're going to mount a volume in the place that they told us to, which was in so capacitor.data dash data is equal to inside the container /var/lib/capacitor. and that's it. Now all the data that's in /var/lib/capacitor will not go missing at any point in time. And what port we want. I actually don't remember what port it runs on. I think it was. So it says that it runs on port 1992. Okay. 1992. And we are good. Did I? Yes. Good, really good catch. I'm getting through. Okay. So now I can say I'm pretty confident that's going to build, but if it doesn't, there's no worry, because if it fails, then it won't push it to the device at all. The current directory and push that to LibLug. It's going to run through that in a virtual machine and tell me if there's anything wrong, and if there is, then it won't push it. And again, this can all be done locally on the machine if you wanted to as well. There's no requirement to use any cloud services of any kind, no botnets. This is the delta diffing I was talking about earlier. If there are any steps that have been executed before on this virtual machine, then it won't duplicate them. So for example, it's not going to have to rebuild the entirety of JupyterLab, Node-RED, and Grafana. It's just going to go ahead and assume that those are the way that they are. So and it tells you which steps have been cached, or which layers have been cached. Layers are separate run instructions. So for example, let's say you run apt-update, and then you do a separate run directive, and you want to run apt-install JupyterLab, and then you want to do a separate run directive and install Grafana. Say you were doing it all in one container for some reason, then you could keep the Grafana run step alone, and then it wouldn't update that. That would be cached. And that seems to be done. And the reason that that's so fast is because it's pulling from the upstream images that have been managed by the project maintainers of InfluxDB and Capacitor and all that. So we don't have to actually do any compiling work necessarily, because they've done it all for us. They provided us with an image that we're just simply pulling and downloading. So we see that the capacitor image is 198 megabytes, which means that 198 megabytes is going to that Pi right now. And it's updating over the air, and we see that it's got a new container called capacitor. And soon, once it's downloaded, it will execute the entry points of that container, or the command that it's been told to run by the Docker file on the source, which we may take a look at in a moment. And it's downloaded, and now it's running. And now capacitor is running on this device. That's right. Yeah. Yes, so you saw that the state of all of those things, the status of all of those containers, was not changed by me having done that. See you later, Jackie. Bye. Damn it. Right, and that's usually the mode of operation, is to be really stable like that. In fact, there was even a blog post about how they put Balena in space, because that's how confident they are with it, where they put a Raspberry Pi into space and are managing that now with containers. Yeah, it's quite exciting stuff. Any questions, by the way? No questions? Have I explained it well enough that there's no questions? We don't get the dashboard, but that's the only difference. We can use the Balena CLI all we want, so everything that I've been doing here, well, arguably all of it has been done with the Balena CLI. I've only ever shown you some neat little things that you can do with the GUI here, like, you know, have a nice little coloured bar to see that Jupyter Lab is running and be able to stop it with a GUI. You don't get any of that with the Open Balena setup yet, because no one's developed that, but I'd really be interested in developing that because that seems like a relatively easy thing to do. So the Balena supervisor, the hypervisor as I was referring to it earlier, is the thing that's controlling all of these containers, just like Docker is the thing that's controlling all of the Docker containers, and just like QEMU is the thing that's running the virtual machine. The supervisor has an API of its own, which is really the selling point of it. I've seen people that have used the API to say, deliver updates to printers over the air, but not if it's printing something, because the application underlying it, like the Octoprint, will report whether it's printing. And then you can say, okay, stop this container only if, and allow an update only if the Octoprint says that the status is not printing. So you can do all sorts of fun things like that if you want to get really complex. For example, there's an optional access point on Ming where you can create an access point and then connect all your sensors to it. By the way, I think the SD card is done. So I'm going to put this SD card in the Pi and then power that up. And before you know it, we're on the botnet, and it's an IoT device and it's got a backdoor to Balena. So within about 30 seconds or a minute, we'll see that has booted up and is then retrieving the head of the current, because all of this is basically just Git. It's retrieving the head of this repo, which is called LUG. In the back end, it all works on Git. Also, just to show you some of the nice functionality that you get with the closed source Balena CLI, the closed source Balena dashboard, is that you can have a public device URL. So if you wanted to tunnel something out on port 80, you can do that. Anything that's running on port 80 on the device, and you click this button, it will tunnel it out. So for example, the Octo Balena setup has this. Right. So you see, Octoprint in this file is being specified to run on port 80. So all of the printers, for example, on this network over here, for example, let's take Alex's CR10S, because it's got a camera. We can access that anywhere in the world using that public device URL. I mean, all of this could be done with the Balena tunneling as well on the CLI. It's got a webcam stream as well. Oh, did you? Okay, damn. It's all right. We'll see it soon because you're always causing trouble. See what happened there. So we see that it's pretty stable in this room. IR on the ceiling. Yeah. That's the temperature graph that we set up earlier.
Where's the sensor though on that file?
Oh, it's not. It's just it's on this MicroPython device that we set up earlier.
Where it's getting that temperature. It's obviously not close enough to the projector. It would be a lot more.
Yeah. Yeah, let's talk about that. So environment variables are an important thing in Docker generally. So for example, let's say I want to make something programmatic that runs in a bash script or something. And I want to say that if the bash script runs and the environment variable Ming_AP equals 1, then it will start up an access point and allow all my devices to connect. So we've actually got one like that around here. I'm going, I don't want to get up and grab it. Do you want to go and grab it, anyone? It's the one with the screen on it on Julian's desk. So, the LUG application, or our personal distribution, let's say, has now got a new device enrolled upon it and can now, well, is now updating itself to be the same as this one, the same as the one that's running on the printer.
They're just random names. You just read them out.
It does give them random names, but you can, of course, rename it yourself. Yeah. So it's downloading all those containers, and the moment it gets the first container, it's going to run it, and we're all good. And doesn't that make life simple? Because imagine doing this on a Raspberry Pi or something like that, with Raspbian on it. You would be manually typing commands all over the place, and at the end of it, have nothing to show for it, because you won't have a big list of instructions that you've made ready to be deployed on any other device in the world. For example, another laptop. My laptop can run all of these containers. Which one do I want to unplug? We've got no Ethernet, have we? That's okay. No, it's all right. I shall demonstrate it on the Pi that I've just set up, since it's running Ming, and it's got the access point, or at least it should have the access points on it. And if it doesn't, we'll push it. I think probably it doesn't have the access points on it, but that's okay. Right, so let's enable the AP, the access points. I decided not to build that in because it happens to cause issues if, well, no, it doesn't cause issues, it's just a bit big. The file size is quite big for what it is. So we simply enable that in the Docker Compose file, and then push it to LibLug again. And it will simply add that container in because, of course, again, delta diffing, it knows what containers have been built before and which ones haven't. And whatever it's downloaded currently will also be applied, I believe. So if it's downloaded a container here fully, which it hasn't, it doesn't look like, then it will no longer need to re-download those either. It'll only download what it needs to download. Yeah. What else have we got? Yeah. More on the boy. Hold on. God, it's getting boring this now, typing this in. Shouldn't have done this.
So what's the story behind this boy thing? It's in Hull somewhere.
It's going to be in Hull somewhere. It's simply going to be a weather centre. I'm about to show you some images of it.
And they're going to float it out somewhere in the sea.
Yeah. Oh, it's a Balena logo. I should have shown that at the start. Right, so that's what the buoy looks like. It's a very simple, well, no, it's not simple at all. I shouldn't have said that. It's a very complex buoy. It's a very complex buoy. Oh, it's taller than this room. Yeah, and it's going to be running Balena, and it's going to have one Pi. It could have multiple Pis, but we haven't done that because we trust it so much, clearly. We're just going to have one Pi in there, one Arduino submitting messages over MQTT, and it just gets numbers. What's that, sorry? Well, actually, the fascinating thing is they want to get mains out, and they feel confident with that.
They want to put mains?
Yeah, they want to put mains out, and they're going to do it, but I don't know how they're going to do it, but they seem confident that they can.
I was wondering if you could have had some kind of propeller thing underneath.
Yeah.
Wave towers.
Or harvest energy from the bashing of the waves.
Solar panel, that'd be better,
Yeah.
In Hull,
No, this is the invisible wind factory, which I've forgotten where it is because I just keep getting driven down to a point. Is it?
If you go past Costco, it's a bit further on.
Yeah.
It's doable.
So I keep going down there with Chris Huffy, and he keeps getting me involved in this project, and I'm like, yeah, okay, cool. And all it's going to do is simply it's going to have a big ring of LEDs around of it, and that's going to be a direction of the wind. That's going to be wind directionality. And then the tip of it is just a regular old weather vane. It's going to have a laser in it which represents symbols and displays symbols. And how's it going to do that? It's going to do it over MIDI. Yeah. It's going to have MIDI values to control the laser because that happens to be what the laser is controlled by. That's what the software is used. And all the Pi is doing is running Ming and visualizing the values and then manipulating the values in Node-RED and structuring what the OSC output looks like. All of the OSC output is being done on software called MadMapper, which is LED lighting control software, which outputs over OSC. And we simply control what ends up in MadMapper with Node-RED. So let's say it's a windy day. If it's a windy day, then it will do a preset animation or something, and that is represented as windy day, as a string or something in OSC. Like, you know, with infinite possibilities of conditionals that you could use. But it's up to us to implement that in Node-RED. So let's take a look at some of the flows, actually. Go. It connects to the internet via 4G, which is some of the benefits of using Balena over anything else, because the binary diffing means that you can say, only update what you need. As I've said a million times now, probably redundantly and annoyingly. But it is such a cool feature that you get to use. Because it does it all automatically. I don't have to think about it. It's got a really good algorithm for determining what has changed and what hasn't. Right. So some of these devices, Ming in particular is quite a big thing at this point, which we could probably slim down a little bit. So it's taken quite some time to get that on the network. Or it might be the fact that the power is also being consumed by other things, which means that the Pi is freaking out a bit. So this is the Node-RED in the Invisible Wind Factory. Tunneled via the Balena CLI, saying that port 1880 there is port 1880 here on my machine. And then we've got a bunch of flows. So let's take a look at some of the flows. We've got gust detection. We actually do, and this is done through a tool called Chronograph, which is part of the TIC stack, which is an InfluxDB invention. And I'll actually show you what that looks like. Let's start another Balena tunnel. So Balena tunnel to the application name, what port we want. Well, actually, hold on, it's on port 80, so we don't even need to do that.
1880.
No, it's on port 80, so I've got it tunneled out to the internet. So let's have a look at that. WinPi, one device. And the thing on port 80 is this, so I could give you any of you access to this if I wanted to do it very easily, which is one of the benefits of using the closed source Balena GUI for now, is that you get all of these nice little functions. So this is doing it. There we go. So that allows you to say, I haven't actually touched this even once, so I've just let someone else do it. So this is data processing. He's saying, take a value that's coming into InfluxDB, take a look at a portion of it, a window of it, and then do some math on that window. So a window of 30 seconds. In those 30 seconds, do some math that gives you a value that you like. And he's using that to determine wind gusts and things like that.
Set the gust variable to true.
I think that's what this...
Yeah, I don't think what it's doing at some level.
Yeah.
Gust.
I think this is it. I think this is it's running a mean difference. Now, I don't know what that means. I'm not that much of a mathematician, but he is. And you can see, well, there's no gust there, and there's loads of gusts here. At least I think that's what it's trying to say. But as long as we can get a 1 or a 0, if there is a gust, we can hopefully make it so that when people walk past this thing, it will start going whoosh, whoosh on the LEDs, and that'll be an immediate response, and you'll be able to see that the boy out there in the middle of the shopping centre is reacting to the environment. in whatever way we can make that happen. Yeah, so that's the boy. It's going to be there.
Okay, so it's just interesting.
Yeah.
Yeah,
exactly.
see, I thought it was going to be in the North
No,
Sea.
not in the middle of the North Sea. Yeah. Although I did say that for a bit.
You're right in the middle of the shopping centre.
Yeah.
That makes a lot more sense. Yeah. Someone could just throw a catch this.
Yeah, and when you put mains out there, you know, Julian said that he wanted a canoe up to it, and I was just like, no, you don't need to do that.
The names in his teeth.
Well, I said it was in the North Sea at first, and so he was like, yeah, I'll get me canoe out and we'll go diving. I was like, yeah, okay. Yeah. So I mean, I'll be honest with you, I think I'm pretty much done, and I don't really have that much more to say.
What about, tell us about how you got a free Raspberry Pi off Balena? What was that about?
If you want to get a free Raspberry Pi from Balena, all you have to do is say that it's really good and do something with it.
Okay.
Yeah.
And demonstrate.
Yeah, and demonstrate it. I mean, I'm pretty sure they'd be quite happy about that if people did that. But I mean, I think it's quite a nice little tool that lets you get on with your life. And if you set up Open Balena, then it can be entirely.
Except you don't get any of that visual stuff.
You don't get any of the visual stuff, but if you're comfortable enough with the command line anyway, if you're doing anything even close to what I was doing with it, you'll be comfortable with the command line. I mean, for example, say I wanted to start a project called Ming, which we have, and I wanted to get people to install this all on their Raspberry Pi. There's no other option. So for example, let's say I could make a blog post that could say, okay, here's what you do. Here's a big script that you run to install Grafana. Then here's a big script that you run to install Influx TV. And when it breaks, I'm not going to give you any help. Whereas with this, it's like, well, it's all source controlled, and if there is a problem, they can raise that as an issue on GitHub or something. And then I can say, okay, here's the change that makes your circumstance work. And that just isn't possible with blog posts that are kind of one way. Yeah. Very responsive. Yeah. Yeah. Yeah, I mean, let's take a look at what exists at the moment.
Do you have to give them up your device?
What's that, sorry?
If they only give you a Pi or something,
Oh no, I was just joking about that. They happened to send me a Pi because I was a good boy or something.
Because you talked about a month specialist free Raspberry Pi.
Yeah.
you said if you have an application,
You should probably use it. I mean, God knows what they'll do. I mean, they seem to be quite happy about the community and telling people about the project and showing people what can be done with it, because it's mostly, it seems just businesses that are on board with it at the moment.
It's one of us to get large companies to pay for the
Yeah.
and like, IoT-based businesses they want them to get on the subscription model for the online cloud, their cloud. But it's still quite new, isn't it? It's not that old, really.
So I've actually moaned a fair bit in the forums. I've grown up a bit, but
You're blacklisted.
yeah, I'm not blacklisted yet. Could have been. But yeah, for example, here's a problem with the community boards, and I said, you know, why the hell isn't it? Why the hell won't you just update it to make it easy for me? And I was just like, well.
Why don't you just do what I wanted to do, which is more sensible?
So it seems that they fixed this for a number of boards. So for example, this printer needed serial drivers, and they weren't installed by default. They weren't part of the kernel for the image that they provide for the Orange Pi 2, because the Orange Pi 2 was hard to develop for and has a bunch of issues, so they didn't bother putting an update on. And so I talked about that, and now it looks like we fixed it 28 days ago on the forums. And God knows what anyone else is doing. So that's just forums.balena.io. Yeah. And I did say I was going to turn this back into a printer, didn't I?
At some point,
Yeah. So now we've got red. No, that's the wind pile. See how this one's doing. It's not doing so well. I think the power's probably weak. The power source is crap. Oh well. Let's turn mass-ender3 back into a Pi. You don't get any of this, but I think you can just move it in the Balena CLI. I think you can just do Balena move something to something, and everything you can do here is just a complete shortcut to everything that you can do on the CLI. Let's turn that into a octopi instance. And it's gone. And now it's going to start downloading Octoprint instead. And actually, as long as the SD card on it was large enough, that will instantly flip over like that to the Octoprint installation because the container already exists. Probably not many. But it's a really nice way of managing devices. But like I said, you do have to learn new things to do it. And it's not like just managing a regular Linux machine. Yeah. Okay. Right, so it got rid of the cache for Octoprint and now it's just downloading it again. Happens to not be that big anyway, so it's not that big of a problem. Probably went overboard here on the time, but yeah. That is going to be a printer and it's going to start printing again. And I suppose I've got nothing else to say. So if you've got any questions, let me know. So, so what did you say, Alex? 20 seconds.
2 weeks. Balena team coming up to show and tell and have a bit of a checklist.
Weeks.
Balena and tell us what they're up to now.
Coming up to have a bit of a chat about what they're up to. On the 22nd of January, yeah. Do you know what? We should. We should.
Can we not 3D print that out?
22,
On the 22nd. Yeah, thanks, Matt.
Thank you. Oh my God! What? I've broken it. How did I break Cowsay? I was supposed to never ran it. I just pressed up by example. Of all the things to screw up, eh?
Well, that's cool. I didn't know. 22nd.
Hey, there you go.
What day is the 22nd? What day is it? 2 weeks. Oh yeah, 2 weeks today. So there you go. Back 2 weeks today. If you want to get people to make it. Oh, there you go, Kelsey. I'll leave it on that.
Yeah, good point.
It'll be about 7 o'clock.
Right. So, actually, do you know what? Let's have a bit of fun. 7 p.m. Does Liverpool clear? No. Does Liverpool on? Oh, do you know, I've got no way of ending this now because I've already said the 22nd of January.
You basically can learn to.
Yeah. 7 p.m. Right, let's just say that. And then we're going to pipe all of that into an MQTT. Sure. I was thinking maybe I could pipe it into an MQTT message and then. Yeah. Actually, do you know what? Let's do this. Let's do it. So we're going to pipe that into.
Somewhere in a canary will be like, what will be? Canary ground loop house or something.
Does Liverpool.txt. Cat does Liverpool.txt. Pub